Okay, good afternoon. The next part of the lesson, it's actually complex numbers, but a little bit deviation in the beginning, but then we come back to complex numbers again. So the title in the book is more on polynomial equations, something like this. Okay, so let me tell you what do we mean by this. Let me just try to start from scratch. So if you have a polynomial, so p of x, is called a polynomial. Every expression like this, a sub n x to power n plus a sub n minus 1 x to power n minus 1 up to a 1 x to the power of 1 plus a node. This is called a polynomial, where these numbers that you see here, these are just numbers. Okay, these numbers are coming from the set of real numbers or in the set of complex numbers. But for the time being, let us keep things simple. Everything is coming from the set of real numbers. So these coefficients, let me collectively call them a sub I, is a real number, and n is a non-negative integer, yes? So n, a non-negative integer. Okay, so that is the important part, non-negative integer. An expression like this is called a polynomial. Yes? So the power is important. It cannot be negative. It cannot be a fractional power or something. For example, this probably the simplest possible polynomial except the constant. So p of x equals to 5 is a polynomial, yes? I don't know, p of x equals to a square root of 3 over 2 is also a polynomial. By the way, this highest power that appears is called the degree of the polynomial. So this degree, if an is not equal to 0, then the highest power that appears there is called the degree of your polynomial. Yes? If I have a constant polynomial, it means that every one of these coefficients that are coefficients of somehow x is 0, and then this constant term is in this case 5, in this case the square root of 3 over 2. So these are actually polynomials, but 0th degree. The degree of these polynomials are 0. And then of course if I want to go a little bit higher, then probably the simplest possible polynomial that you can imagine is p of x equals to x. Yes? What is the degree of p of x equals to x? The highest power of x that appears is 1. That's the degree 1. Or I don't know, p of x equals to ax squared. So I would write 2x squared plus 5x negative square root of 3. That is also a polynomial. If I ask you what the coefficients are, it would say 2, 5 minus the square root of 3, and the highest power of the variable which appears is 2, so that is a second degree polynomial. Yes? So if you don't mind, let me change this. So that is the meaning of a polynomial. And when I talk about polynomial equations, it means that I have an equation in which a polynomial is involved. Yes? For example, this 2x plus 1 equals to 0 is a polynomial equation because the left-hand side is a polynomial of degree 1 in this case, and I want to solve it. So it's an equation, and it is a polynomial equation. Okay, I can also talk about this, yes? 5x squared plus 2x negative 1 equals to 0. That's also a polynomial equation. But the polynomial equations of degree 1 and degree 2, we don't have any problems with, yes? Polynomials of degree 1 can be easily solved by making x alone on the left-hand side. But when I have the second degree, I can use the ABC formula to solve it. But if I start increasing the degree, it becomes a hard problem. Yes? And of course, for the third degree, there is another formula which is more involved than ABC formula, and that is called Cardano's formula. You can check it on the Google to see the formula is more or less complicated. But for the fourth degree, we can also have a formula which is also complicated. But Norwegian mathematician Abel actually showed that there is no closed formula for polynomial equations degree 5 onwards. Yes, it doesn't mean that we cannot solve any kind of fifth degree polynomial equations. Yes, we can. If I give you x to power 5 is equal to 1, it's a polynomial equation because the left-hand side is a polynomial of degree 5. And if I ask you to solve it, you can immediately answer the x is equal to 5. But it means that if I write a generic fifth degree polynomial, I don't have any formula available to be able to find all the roots of that polynomial. Yes? That's what I want you to at least understand. That if I increase the degree of the polynomial, solving that equation becomes harder and harder. Okay? But here in this lesson, we want to talk a little bit about a higher degree polynomial equations. The only thing we can do to be able to solve it is to be able to factorize the polynomial. Yes? For example, I can start from this one, x to the power of 3 plus 5x squared plus 6x equals to 0. This is a third degree polynomial, but one of those types that I can easily solve. Why? Because factorizing the left-hand side is very easy here. So what can I do? I can factor an x out, then this becomes x squared plus 5x plus 6 equals to 0. This is only working if on the right-hand side I have 0, because I want to use the zero product rule. This is a number, this is another number. They have been multiplied, and the answer is supposed to be 0. This cannot happen unless at least one of them is 0. So this means that this is equivalent to saying that x is 0 or x squared plus 5x plus 6 is equal to 0. Okay, x equals to 0 is already solved. But this one, in principle, I don't have any problems with that because that is a quadratic equation and I know how to solve it using PQ formula or ABC formula. And then you start solving this, so I don't want to repeat it, you solve it and then you get two answers. One of them is -2, the other one is -3. So it means that this equation, which was of degree 3, got 3 solutions here. Yes? And there is a theorem in mathematics that a polynomial of degree n has at most n roots, not more. But there is no guarantee it has exactly n roots, unless you are working in complex numbers and you're also counting repetitions. I will talk about them, what I mean. But for example, let me just change this equation to this equation, you know. X to the power of 3, I would write 5x squared. Then instead of having 6, let me have 7. 7 words, yes. 7x equals to 0. So you see, this is a third degree equation again, but I want to solve it. What do? I will factor an x out. This becomes x squared plus 5x plus 7 equals to 0. Then again, the same story. The product is 0, so either the first one is 0, which is already my solution, or this one is 0. X squared plus 5x plus 7 is equal to 0. Yes? Now, if you want to solve the second one, let us just try to solve it. What happens? X becomes equal to ABC formula minus b plus or minus a square root of b squared, which is 25, minus 4 times 1 times 7, it is 28, and then divided by 2. And then suddenly what happens? This becomes minus 5 plus or minus a square root of minus 3 divided by 2. It depends. If I ask you to solve this equation in the set of real numbers, then you will stop here and say that the only solution to the problem is x equals to 0. Yes, because this is not acceptable in the realm of real numbers. It is not a real number. So it means that if I didn't say anything, it means by default I mean the real numbers. If I want to mean complex numbers, I have to mention it, yes? Solve it in complex numbers. So if I just say solve this equation, or if I ask you how many solutions are there to this equation, you will say only one, and that is x equals to 0. But if I ask you to solve the same equation, but in the set of complex numbers, so then it means that you can also continue and write this in the complex form. But you see that in the real numbers, I have one solution only, even though the degree is 3. But if I ask you to solve this in the complex numbers, you again get 3 answers. Yes? What are the answers? Let me just write them down. So if I want to write it in complex numbers, so it becomes -5 plus or minus. Instead of that, I would write the square root of 3 times I divided by 2. So there are 2 answers, -5 over 2, either plus or minus a square root of 3 divided by 2 times I. So that is the solutions of this equation in the set of complex numbers. But you see that still I have 3, not more. I can have a third degree equation, but with less numbers as roots. For example, I can have x to the power of 3 plus 2x squared plus x equals to 0. Assume that I want to solve that. Then what happens? I factor x out, it becomes x squared plus 2x plus 1 equals to 0. But then suddenly this becomes a squaring pattern, so I can write it as x plus 1 to power 2 equals to 0. And then if I ask you what are the solutions, there are 2 solutions, yes? So one solution is 0, the other solution is what? -1 or -1. Okay? But of course, -1 is repeated 2 times because you can pretend to write the last one in this form, x times x plus 1 times x plus 1 equals to 0, yes? So this means either the first one is 0 or the second one or the third one, but the second one and the third one gives rise to -1. This is a term I want you to know about it, but this is not probably mentioned. That is called algebraic multiplicity of the root. Algebraic, so I would say that how many roots are there? 0, 1 root, -1, 1 root. But the algebraic multiplicity of this root is 1, it is repeated once. But algebraic multiplicity of -1 is 2 because I have a power of 2 here. In principle, it repeats itself 2 times. But that's the terminology, it's good to learn. Okay, but if I want to work with real numbers, you see again, I have a third degree polynomial. I have only 2 roots. Even if I want to work in complex numbers, these are the only ones. So I have a third degree polynomial, but with only 2 roots. Yes? So the number of roots is at most 3. But if you consider algebraic multiplicities, and if you consider the complex numbers, then that is exactly 3. So here, this is 1 root, this is another root, 2 roots, but the algebraic multiplicity of this one is 2. So I can pretend that this root is appearing 2 times. So this becomes 1 time, 2 times, here 3 times. So then if you want to work with complex numbers and consider algebraic multiplicities into account, then you can say that every polynomial of degree n has n roots in the set of complex numbers. Okay, but what I wanted to mention by these sort of examples is that the reason that I could solve the problem was because I was able to factorize this. Yes, so let me write another problem here on the board for you. So I would say that let us solve this equation. So x to the power of 3 plus 2x minus 3 equals to 0. So now I want to talk about this equation. That is also comparable to what we had before, yes? Yes, it's comparable to what we had before, but you will see that suddenly it becomes much harder. The reason that this becomes much harder, not much harder, might be if you are not very experienced in factorizing, it would be much harder. But anyway, factoring polynomials is a really hard subject. It's not that easy to factorize. Algorithmically, you can factorize any polynomials that are factorizable, but using that algorithm is not that easy. Okay, but anyway, if I ask you to solve this, at this point, I ask you to solve this, there is only one way you can do it. Try to factorize it. Okay? But then factoring this is not probably very common in the education that you got so far. Okay? But do you have any idea how to factorize this? Factorizing it means I should be able to write this as a product of two polynomials at least. Okay, because might be you don't have that experience, but you need to, because I know how to do these things. If you make this complicated, even I don't know how to do it, okay? But I just want you to feel a little bit what's going to happen. To factorize this, the trick is to write minus 3 as minus 2 minus 1 equals to 0. Okay? You might say why, you have to be patient to see why it works, okay? So what I do, I will take this minus 1 with that x to the power of 3 and put them in one group. And between these two, I factor a 2 out and put them in one group, yes. And there is always a formula in the formula sheet that you usually don't use it. I want to use it today. So I have this formula, a to the power of 3 minus b to the power 3 is a minus b, a squared plus ab plus b squared, yes? Okay, now let me replace a with x, replace b with 1. Let us see how it goes. Then this becomes x to power 3 minus 1 to power 3, which is 1, is equal to, instead of a I put x, instead of b I put 1 everywhere. This becomes x minus 1, x squared, a times b is x times 1, and b squared is 1. Yes, so that is factorization of this part only. So I come back here and I would write x minus 1, x squared plus x plus 1, and then I have plus 2x minus 1 equals to 0. And then you see that x minus 1 is common here and there, so I can factor it out again. So what is left for me is this part, and what is left here is that part. Yes? That's it. Because this becomes x minus 1, x squared plus x plus 3 equals to 0. You in principle shouldn't have any problems to solve this one, yes? I told you that this is a little bit hard method, but don't worry, I will tell you what to do now. But if someone tells you how to factorize, of course, you factorize, and then the rest of the problem becomes simple. Because then you can immediately use the zero product rule and say that either the first one is 0 or the second one is 0, yes? If the first one is 0, of course, x becomes equal to 1. But if the second one is equal to 0, it is important to tell you on which set I am supposed to solve it. Let us solve, because this is the lesson in complex numbers, let us solve in complex numbers, because I hope that you agree with me there are no real roots here. Because that's a quadratic equation, it becomes minus b plus or minus the square root of b squared minus 12 divided by 2. Minus b plus or minus b squared minus 4ac divided by 2. And then you immediately realize that I am in trouble if I want to work with real numbers, because under the square root I have a negative 11. But then if I want to solve it in real numbers, I will stop here and say that this is the only root. If I want to work it in complex numbers, then I can complete it and write minus 1 over 2 plus or minus the square root of 11 over 2, but multiplied by an I. So, I hope that I could convince you somehow that factorization is a vital part here. Because if you factorize, you break the degree of your polynomial. This polynomial was third degree, hard to solve, but if I succeed to factorize it, I break it into two polynomials, one with degree 1 and one with degree 2, and I already know how to solve them. Of course, if I have higher degree polynomials, for example, if I have a polynomial of degree 7, if I factorize it, might be I get two polynomials of degree 3 and one polynomial with degree 1. Then, of course, the problem is still hard because the third degree polynomials are hard to solve. But at least, I hope that you agree with me that this third degree polynomial equation is probably simpler than the seventh degree polynomial equation. So it means that at least we can simplify our problem. Yes? Okay. But the thing that I want to teach you today is actually a method for factorizing, not from scratch. If I give you one piece of information, I want to teach you how to use that one piece of information and use a method that you need to learn, that is the long division method, to factorize the polynomial. Okay, so for example, this is the typical problem that you face in this section. So let me write this as an example. Show that, so consider the equation. This is important, by the way. This is the type of question that you might face. Okay, consider the equation. I will give you the same equation. X to the power of 3 plus 2x minus 3 equals to 0. Number one, this is usually given in the book, in the questions in the book. They give you some kind of very simple investigation which will help for you to solve the problem. Okay? The number one, show that x equals to 1 is a root of this equation. Okay? Number two, solve this equation in the set of complex numbers. Yes? I just want you to understand, if they give us to check that x equals to 1 is a root, it doesn't mean that they have given us the solution. It's a partial solution, yes? Because we might expect 3 solutions, they have given us only one of them, but they're expecting us to find the other 2. I want you to understand, the problem is not fully solved, even if they have given us one root. There might be other roots that we have to find. Okay. So let me solve this one. The first part is very simple. Actually, I told you that always the reason that they give you this because they want you to guide how to solve the problem for the next part. So I will check 1 is a root. So what I need to do, I replace x with 3. I replace x with 1 and ask myself, is this equation, is this equality true or false? But immediately it reveals itself that this is true. Yes, 1 plus 2 is 3 minus 3 is, this is equivalent to saying 0 is equal. Yes? But now, this is the new lesson. I want to tell you how to use that piece of information provided in the first part to be able to factorize your polynomial without being creative. Because here, I told you that I was a little bit creative based on my experience. If you start changing these numbers just a little bit, I can also get stuck. I cannot be able to solve it. But if you give me that, I can systematically still solve it. That's the difference. But of course, the price that I have to pay is that someone should provide me somehow with an extra piece of information. Okay? Here, I solve it completely from scratch without having access to the first part. Okay, which is not the part of your lesson, not part of your lesson, but here. For the second part, I want to teach you a new algorithm That is called the long division. Yes? And I will use the notation in the book. The American books are writing this symbol differently. I will follow your book here. So what you want to do, first of all, I want you to understand, how do you think this will help me, this piece of information? Yes? If you don't mind, let me call this part, just this part, polynomial p of x. In the first part, I showed that p of 1 is 0. Yes, this is the first part. I replaced x with 1. I realized the answer to the polynomial becomes 0. This means that this polynomial p of x is factorizable. That is for sure. And we also know that this polynomial should be something times something. When you say that x equals to 1 is a root, it means definitely your polynomial is factorizable. But you already know one factor of it. What factor is that? You want to have a factor so that when you replace x with 1, it gives you 0, so that when it is multiplied by everything else, the answer becomes 0. Because you know that p of 1 is supposed to be 0. So it means that when you factorize it, one factor should be clear for you. What is that factor? What? X minus 1, yes. But this factor is not clear. At least something about this factor is also clear. For example, what is the degree of this factor? We know that the degree of p is 3, so the product should be a third degree polynomial. This one is the first degree, so this is a second degree polynomial. But let us just get rid of it and write q of x. This is another polynomial of degree 2. So I just want you to make sure that you understand. Yes? Do you understand that? In the first part, we checked that p of 1 is equal to 0 based on the guidance in the problem itself. And because of this, I conclude that p of x is x minus 1 multiplied by another polynomial with lower degree. Yes? Okay. Now, this means that p of x is divisible by x minus 1. Do you remember when you write 6 equals to 2 times 3, you can say that 6 is divisible by 2. You can say 6 is divisible by 3. Here you can say p of x is divisible by x minus 1. P of x is divisible by q of x. So it means that if I ask you to find the second factor, what do? You divide 6 by 2, becomes 3. 3 is the second factor. So if I ask you find q of x, one way is to divide p of x by x minus 1, which you didn't know how to do so far. Because that is not a number. That is not a number. That's a polynomial. That is another polynomial. I want to divide them. So this is the topic of the long division. That's content. Okay? So what you do, you write your polynomial. So learn this algorithm now. This one. And then you draw something like this according to what is written in your book. And then you put x minus 1 in front. Okay, and then let me see what they have done. On top they put something, yes. They put, I don't know. American books, they write it somewhere else. But anyway, here you only take the first term. Be careful. I am dividing this polynomial by that polynomial. I will take the first term of this one only and the first term of this one only. Before doing that, I have to mention that you have to respect the order. You have to write the polynomial in descending order of the power. I cannot write 2x first. I have to write x3 first, 2x second, and 3 later. Okay? The same thing for here. So first of all, you organize them. And then you start dividing. So divide x to power 3 in your head by x. If you want, you can go to a scratch paper. X to the power of 3 divided by x, the answer is x to power 2. Put x to power 2 here. And then multiply x power 2 to the whole expression and put them below this, but change the sign of each term. So x squared times x is x cubed, but don't write x cubed, change the sign, it becomes negative x cubed. You multiply x squared by negative 1, it becomes negative x squared, but don't write negative, change the sign. Okay? And then what you do, you draw a horizontal line, you add this polynomial that you got in this way to the polynomial you had before. So this minus x3 when added here will cancel this positive x3. x2 is alone, yes, because x2 cannot be added to these terms. So bring it just down. But in the order, in the organized order as I mentioned. And then bring 2x down and then minus 3. Yes? Mm-hmm. And that's it. Repeat this process until you get 0. You will get 0 because this means that this is divisible by that. It will continue to 0. What does it mean? It means that completely forget about what you have done so far. Assume that you want to start from here and there. Again, take the first term only and divide it by the first term. X squared divided by x is x, of course positive x. So you put positive x there. And then you multiply positive x here and there and write it with opposite sign here. So x times x is x squared, but you write negative x squared. X times minus 1 is negative x, but you change the sign and you write positive x. That's really unfortunate, okay? So what happens? It's a very, very bad situation, sorry, but let us see. This one and that one are gone. And this x added to 2x becomes 3x. Let me write here. And then minus 3 is alone, so I bring it down. Yes? But still, this is not 0, so you have to continue the same process. But you see, I am not creative at all. I am just following an algorithm. Here, I have to be creative. For example, there were many ways that I could break minus 3. Why should I choose this only combination that works? Okay, so if you change the problem harder, I cannot guess those numbers. Okay, so now I divide 3x by x, it becomes 3 again. The first term by the first term. So then it becomes positive 3. I put it here and I do the same process. 3 times x is 3x. I change the sign. Sorry for the mess. And 3 times minus 1 is minus 3. Change the sign, positive 3. And finally you get 0. Because when I add this one to that one, 0. Add this one to that one, 0. And then what you get here is exactly what I had here. Okay? Is that understandable? The algorithm of long division is a method to provide you the second factor, if you know the first factor. Of course, if you don't know the first factor, it doesn't help. But if you know one factor, it will help you to find another factor, which is good, especially for third-degree polynomials. Because if I know a factor, the second factor would be a second degree, and I know how to solve it. Yes? Is that understandable? Yes or no? Okay. So, and then, of course, if you want to do it properly for this problem, what you do, you would say that therefore, this expression that I had from the beginning is x minus 1 times x squared plus x plus 3. And then you can continue. And the rest of it is from here to here. Yes? So this only helps factorization part. The rest of it is as before. Yes? So you have to continue the rest of it. Any questions? Okay, so let me give you an exercise to practice about this long division in a better position, location in the board. Yes, that was a mess. So let me write this question. Example. Show that I can change the question a little bit. Hopefully this will work because I don't have the solutions in front of me, but let us just do it together. Show that x squared plus 1 is a factor of the polynomial of p of x equals to 3x to the power of 4 minus 2x cubed plus 2x squared minus 2x minus 1. Then solve p of x equals to 0 in the set of complex numbers. Yes? Hopefully this will work. I don't know. I don't have the solutions here. Yes. That is also another way to phrase the question. Yes, here I have mentioned that show that x equals to 1 is a root. You checked it, and you yourself understood that therefore x minus 1 is a factor. Yes? But here I am not just, I'm making it simpler. I am just proposing that show that x squared plus 1 is a factor of this polynomial. There are two ways. One way is that I am so creative that I can really factorize it without this long division method. And when I do the factorization, I see x squared plus 1 appears as a factor. Of course, that is completely correct. But the point is that it is not that easy to understand how to factorize this fourth degree polynomial. But the one factor is being proposed. The way that they have stated the problem, they're also guiding you. That show that x squared plus 1 is a factor. If it is guaranteed to be factor, then I know how to factorize it, at least partially. How should I do? I will start writing this. Remember, you have to keep the order in descending order of exponents. So both for this one and for that one. So I would write 3x to the power of 4 minus 2x cubed plus 2x squared minus 2x minus 1. Then I draw these weird lines. And then I put x squared plus 1 in front. And I start doing the same process as I told you. Hopefully this time I will not run out of. So let me make it smaller. That would be a disaster this time. So 3x to the power of 4 minus 2x3 plus 2x squared. Oh, that's not working. Okay, so if you don't mind, let me clean this line, yes? Then I was supposed to solve the equation, yes? I don't think it will fit, okay? So what I do, I would write 3x to the power of 4 minus 2x to the power of 3 plus 2x squared minus 2x minus 1. And I do this, x squared plus 1. Okay, I told you what to do. Take only the first term and the first term, and then divide. So if you want, you can go to scratch paper, but you really don't need. 3x to the power of 4 divided by x squared. If you just divide this, it becomes 3x to the power of 2. Yes? Let me double check that I haven't written something wrong, because that would be troublesome. Yes, everything seems right. Okay. So if I put this number here, this becomes 3x squared. Okay. And then I multiply this not just by the first term, but everything you see here. And then write it below here, but with the opposite sign for each term. So 3x squared multiplied by x squared is 3x to the power of 4, but I change it to negative. And then 3x squared multiplied by 1 is positive 3x squared, but I change it to negative. And be careful, don't make a mistake here. So whatever you get here, you add it to the previous line. But of course, you have to add similar terms. This one and that one are similar and opposite, they are gone. But this is 3x squared, this is x cubed, they are not similar. But this one is similar with that one with lower power. So I have to bring this down first. Yes? And then add these two that are similar. It becomes minus x squared. But this one and that one are alone, so I bring them down, yes? Just without touching them. Is it clear?
Can you just repeat
the last step? So you take the first term, and then you take the first term, you divide, whatever you get you put up there, and then you multiply this not just by the first, by everything you have here, and put them here with opposite sign for each term. Yes, and then add them term by term. But be careful. For example, not everything below each other should be added because x squared cannot be added to x cubed. But this can be added here. But don't be in a hurry to add this one here and bring it first, because I told you that you have to respect the order of powers. Okay, and one more step. You have to continue this step. If the claim in the problem is correct, I will end up with the remainder 0. By the way, that one is called the remainder. So this number that you get here is the remainder. I will tell you what to do. If you, in this context, we only need the remainder 0, but that's not always the case. Okay, so you divide this by that. In your head, you can do it, yes? Minus 2x cubed divided by x squared is minus 2x. And then you write minus 2x here. Multiply minus 2x by the whole expression. Write every term here with the opposite sign. So it becomes minus 2x cubed. It becomes positive 2x cubed. I have changed the sign. Minus 2x times 1 is minus 2x. And then I change the sign. Positive 2x. And then finished. I have to add them. When I add this one and that one are gone. This one cannot be added to this one because that's x squared, that's x, but this one can be added to this one. Unfortunately, that is gone. So what is left? A minus x squared is left, I bring it down. A minus 1 is left, I bring it down. I'll repeat the process again. You see it's algorithmic. So I will take the first term again, and I take the first term here, I divide. This time I get minus 1. I put minus 1 here. And then what to do? I multiply this minus 1 here, so it becomes minus x squared, but I change the sign, so it becomes positive x squared. I multiply minus 1 here as well, it becomes negative 1, but I change the sign, it becomes positive 1. And then I add them. But then I am done, yes? Because both of them suddenly are cancelled and nothing except 0 is left. So when you get this is called the remainder. So let me write the names. So this is the remainder. This is called the divisor. The whole expression here that you get is the dividend. And then finally this one is called the quotient. So these are the words that we phrase them. There is no guarantee that the remainder is always 0. The remainder is 0 if the polynomial is divisible by that polynomial. Otherwise, it is not. Yes? Okay, so the first part is finished. We were supposed to show that this is a factor. It means that show that this is divisible by x squared plus 1. We did the long division to find the remainder, and find the remainder is 0. So it means that this is divisible. It's a factor, yes? So this means that x squared plus 1 is a factor, is divisible. Sorry, it tells you that p of x is divisible because the remainder is 0. It is divisible by x squared plus 1. In other words, x squared plus 1 is a factor of p of x. Yes? Okay, but then they have asked you to solve equation p of x equals to 0, which was a hard task to do. It's a 4th degree polynomial. But with this extra piece of information, it's actually very simple now. Of course, very simple. I mean that you don't need to be creative at all, even though this is lengthy, but you don't need to be creative for doing this algorithmic way. So, first of all, I have to write the factorized form. So what I do, I would say that, okay, therefore, what is p of x? P of x is equal to x squared plus 1 multiplied by the quotient. So x squared plus 1 multiplied by 3x squared minus 2x minus 1. Yes? So actually that is a good progress, yes, because we were able to factorize this non-trivial polynomial to the factor of 2 polynomials, both of degree 2 in this case. I am not claiming that this is fully factorized because, first of all, it is clear that this cannot be factorized if I am working with real numbers, but this might be still possible to factorize that one. I'm not saying this is fully factorized, but this is at least partially factorized. And this problem is simpler than this problem. So if I want to solve p of x equals to 0, it was hard to start from here. I don't know what to do, but now I know what to do. Because here, this means that the product of 2 polynomials is supposed to be 0. This means that either x squared plus 1 is 0, or 3x squared minus 2x minus 1 is equal to 0. But because I am asking you to solve it in the set of complex numbers, so it means that I have to continue here. X squared, I move 1 to the other side, it's minus 1. So x becomes plus or minus a square root of minus 1, but this makes sense. That is I. So this becomes plus or minus I. 2 roots are these numbers. And this one I have to solve again, but I don't have any problems here. I can use ABC formula. So this means that x is equal to minus b, which is 2, plus or minus a square root of b squared, which is 4. 4 times this one times that one, so it becomes plus 12, divided by 2 times this number, 6. Okay, so that is not a complex number anymore. So this becomes 2 plus or minus 16. The square root of 16 is 4 divided by 6. Then I get 2 answers. One of them is 2 plus 4 divided by 6 is 1. And the other answer is what? 2 minus 4 minus 2 divided minus 1 over 3. So you see, I get 4 answers. So this polynomial in the set of complex numbers has 4 roots. But if I just say how many roots are there without mentioning the complex number, then you would tell me just 2 roots. There are 2 real roots. Okay? And by the way, that is also good to know. If you use GeoGebra to draw the graph of this function, how many intersection points do you expect to get with the x-axis? Because you know that the intersection point of a graph with the x-axis is the zeros of that function. Here, if I ask you how many zeros are there, I have to make it clear. If I mean how many zeros are there in the complex numbers, you will tell me 4. But if I ask you how many zeros are there in the real numbers, you will tell me 2. But if I draw the graph of this, which one do I get? I will get 4 or I will get 2. I will get 2 intersections with the x-axis or 4 intersections with the x-axis. Definitely I will get 2, yes? Because if you want to get 4, it means that somewhere on the real axis, one number is I. But on the real axis, we do not have any i's or minus i's. They are on the vertical axis. So remember, if you draw the graph of this using GeoGebra, this graph will intersect the x-axis in 2 points only. Okay? Okay, any questions here? This I will not consider it complete. I will complete it later. But this is the main thing that I want you to learn. So we just learned the general technique for solving a higher degree polynomial is to be able to factorize it. But factorizing it without any extra piece of information provided for us is not that easy. But if they provide some piece of information, we can exploit that piece of information and the trick of long division to do it not shortly, but lengthy, but without any creativity. Yes, we just follow the algorithm, and then we can solve the problem. But then one question is that, is there any way that I can get this extra piece of information somehow myself? Yes, I would say that no, there is 50-50 chance that we can do that, but I can express a theorem for you, at least where to look for. But unfortunately, that theorem is not always guaranteed to work. That only works if you have an integer solution. But that is also a good thing, because most of the questions in the book on, I don't know, exams, they always care about integer solutions. So I would say that yes, for this one, I will tell you how to find this without providing it for you, okay? So you can find this. But if the answer is supposed to be a very strange number, a rational number or whatever, it is not that easy to find it using that theorem. But we haven't talked about that theorem, we'll talk it later. Any questions? Okay, thank you.